it's going. And hopefully now you can see the presentation. If you can't, you let me know.
I see it.
We'll go from there. So we're going to talk this morning for a little bit about Marathon's safe work practices. This is one of their standards. It's their standard RSP 1162. They have been auditing various contractors, from what I understand, and some of the contractors didn't do very well in the audit, so that's part of the purpose for us to review this. And we really haven't went over this specific one as a group, to my knowledge, recently, so it's not a bad deal. So when we start talking about this policy, it's basically Marathon's safe work policy. And it has roles and responsibilities, and the roles and responsibilities are laid out for various groups. And they have one section for managers and supervisors of Marathon themselves, uh, what they're responsible for, and then they have a group for the electrical foremen and electrical supervisors of Marathon themselves. Then they have the electrical reliability group of Marathon that has their roles and responsibilities. Project engineers, their training department, their safety department. So it's itemized out specifically for each individual little section. And then there's a section that says qualified persons and contractors. And so that's the section that we're going to focus on today, to talk about what our roles and responsibilities will be at Marathon sites. So number one is our primary goal there is to ensure that we have electrical safe work practice, that this policy is utilized for all electrical work that we do there. Now, I will say that there'll be a couple, three areas where we talk about that Premier's policy may be a little more stringent than Marathon's. There are some places where Marathon has some procedures, and even if you follow those procedures, you would still have to go through procedures for Premier. Not that they disagree, but just for various sections, for instance, an energized work permit. Marathon has their process to go through that. And just because you go through that doesn't mean you're free to go and work on something energized, but you would have to go through Premier's permitting process as well. So understanding that this safe work practice is utilized for all of our electrical work. And number two, ensure that requirements that are specified in this section are followed. And again, there's going to be some areas there that differ just slightly from what we do. Uh, and we'll try to address each one of those individually as we go along. Uh, if during the day, during the process, uh, we, you find something that just doesn't line up exactly with Marathon's safe work practice, uh, that work is to be suspended. Now, we talk an awful lot about the ability to stop work at Premier Power Maintenance. I don't get a good feeling all the time that we truly endorse that from every person in the field, that they just have a little bit of problem enforcing the stop work thing, that they just feel a little guilty about stopping work, or they feel a little concerned that they may be making a mistake. Uh, but we're supported here again with Marathon's policy that if anything doesn't look right, anything doesn't follow their policies, basically that work is to be suspended. It shall be. It's not. It's not your right. It's a mandatory requirement, and that's pretty much the way it should be at every location. Then we have an obligation to make sure that we have the proper PPE and all the proper safety equipment, and we use it properly, and we return it back to its proper location. Uh, and finally, under their list for roles and responsibilities uh, for contractors, that when we work on that plant electrical equipment, we have to make sure it's properly labeled. So if you don't see a piece of equipment that's properly labeled, that's a stop work situation. If it's already down, then that's a situation where it doesn't come back energized until it is properly labeled. Uh, Make sure it's in good operating condition. It's never acceptable to fill out a test sheet where something may be questionable or something may be marginal. Let it come back in service and then tell the customer the next day. That's never acceptable anywhere, but Marathon specifically puts it down in writing. In any deficiency that we may note, it needs to be addressed to the electrical foreman or the electrical supervisor that we're working with. So those are basically the roles and responsibilities that we have uh, with uh, with regard to their electrical safe work practices. Now, when we get down to actual requirements, training requirements, so there are specific training requirements that we are have to do. First of all, to be qualified. Now, uh, we understand, or we should understand, that being qualified uh, to Premier and to OSHA means that you truly understand whether something's energized or not. You know whether what voltage level it's energized at. You know ahead of time how close you can safely work around that, and then you know what you have to do if you have to violate that safe work clearance. So those are the basic rules, and then NFPA 70E added an additional one in 2018, saying that now you have to not only know what the hazards are, but be able to mitigate those hazards. So those are the basic steps for qualification. Uh, but Marathon has added some additional to that. Now, uh, they say that safe work practices, uh, basically, you got to be trained in and familiar with all the electrical safety related work practices that's required by this policy and by Premier's policy and by the particular job that you're doing. You need to be trained on personal protective equipment. I mean, that includes selecting the proper arc flash clothing, the rating of the shirts, the pants that you've got on, the proper hard hats, the proper gloves, all those sorts of situations, any kind of shielding material, any other personal protective equipment. You need to be trained on that. When it comes to insulating tools, you need to be knowledgeable of each piece of test equipment in its use and in its ratings. So basically, this kind of supports what MSHA tells us to do. Uh, we don't do a very good job of that sometimes, but basically, you need to be trained on each piece of equipment that you're going to operate. Excuse me. You need to understand the ratings of that piece of equipment. You need to understand that when you're wearing low voltage gloves, what's the voltage rating of those gloves. You need to understand that when you use your fluke meter to take a reading, a voltage reading, you need to understand the ratings of that fluke meter. Is it 1,000 volts rated? Is it 600 volts rated? Is it Cat 3? Is it Cat 4? You're required to know that. If you're using a hot stick, what's the rating of that hot stick? Uh, every piece of equipment you need to know, have some training on what you're doing to use that equipment and what the ratings of that various equipment is. Now, you also need to be knowledgeable of the live line tools. We talked about that. Uh, and you need to be trained and knowledgeable in the installation and removal of temporary protective grounding equipment. Now, I don't know whether we install any more grounds at the Marathon facility. Normally they did that, but we'll talk a little bit more about grounding in just a little bit. So,
Hey, Alan, just let you know, they still pretty much apply all the grounds and stuff unless we decide we want a personal protection beyond theirs. We ask, and a lot of times we get that permission and they can do that.
okay, Jay, and one thing I noted that was going to discuss a little later, but since I'm here now, and we talked about it, we are not permitted to use our personal safety grounds on Marathon site. The ones in the back of your vans are not acceptable for use on their site.
Good
Uh,
deal.
their 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 policy, according to this work policy, is that they have to be manufactured somewhere and meet ASTM standards, and we make our own ground sets, so ours would not be acceptable use for on Marathon site. Uh, so installing and removing grounds, that's part of the requirement that we've got to have. We need to be knowledgeable in emergency procedures. and the emergency procedures. Everybody should be fully up to date on these. Electrical contact release, we do that on an annual basis. You get that as you hire on as a new team member here. CPR first aid, you need to be CPR first aid trained. That certification needs to be up to date. That lasts for every 2 years. Lockout, tagout training, everybody's received that. By requirement, we have to receive that every 3 years. And at Premier, we do that on an annual basis. So those are the requirements that they have for the training. And of course, NFPA 70E training, we do that annually. Marathon and the regulations say that we have to do it every 3 years. So audits. Electrical safety program shall be reviewed every 3 years. So our program is reviewed. Wes Anderson's responsible for reviewing that program. But here's a big key that when you're on a marathon site, you're going to be there for a while. You ought to do a field work audit. So there are field work audits that have to be done annually, and I would think it would be a really big plus if we were on site if we actually did a field work audit while we were there doing their job at that site. Okay, general safe work practices. Get into a little more detail here. When you look at what they're specifically discussing, safe work practices shall be utilized to safeguard from personal injury. Okay, so the big thing is we're trying to take away a situation where there's any kind of personal injury possibility. If there's a possibility of a personal injury, we can't do that. We're going to do things that we're going to take steps. We're going to provide adequate PPE. We're going to do engineering changes. We're going to use the hierarchy of control of risk mitigation, where just eliminate the hazard. Substitute something so that we can minimize the hazard. Engineering controls, those three areas, what we're really going to focus on. But basically mentioned in their section is like while performing diagnostic tests, while performing repairs, and while performing maintenance and modifications. So the diagnostic tests are where we're going to be concerned about. And we've been aware, and we've actually found a couple, 3 times on various sites where electrical work clearance, safe work clearance was supposed to have been in place for us, and we found some stuff still energized, some backfeeds. So it's important that we as a contractor stay on top of that. Any repair or installation of equipment has to be performed by a qualified individual. So we need to be mindful of that, we make sure that if we do repair, when we do cleaning, those sorts of things, that we may not have a senior individual doing every aspect of the cleaning and inspection, but we need to have a senior individual actually reviewing all of that work that's being done. Then we need to have care. When we're opening energized electrical equipment panels. So we need to understand that in certain areas, if it's called an electrically classified area, that before you can open an energized piece of just open the door, if it's energized behind that, that would require a hot work permit. The hot work permit is much different than the energized work permit, but it is a permitting process that you would have to go through with Marathon in order to open a panel door with energized equipment in it if it was in a special area, electrically classified area, where there could be explosives or flammable atmosphere available to us. Now, some other safe work practices that Marathon specifically points out. After a circuit's de-energized, and by being de-energized in this part of the process means that a protective device, a protective relay, a trip unit on a 480-volt breaker, something has caused that to be de-energized. So it's tripped offline, okay? That shall not be re-energized until it's been determined that all the equipment in that circuit can be safely energized. Okay, so basically a cause has to be found when something trips off. They don't want just to be re-energized. When it's determined that the operation of a device was caused by just an overload rather than a fault condition, they still have to examine it. So there are certain circumstances, but all these decisions are made by the Marathon electrical people. You just don't reclose something that's tripped. Then the use of safety signs, safety symbols, uh, or any kind of tag that might prevent an accident. They're going to be used whenever necessary uh, in order that we can caution people about electrical hazards that are in the area. Okay, so we need to understand the red and the red tape do not cross, the yellow tape, the caution tape. We need to utilize those, and it's not just for Marathon site, but we need to utilize those for us. Now, when it comes down to actual working on equipment modifications. Now, a lot of these things we wouldn't do, but sometimes we do for some of our customers. Uh, Overcurrent protection. They can't be modified beyond the standards permitted by NFPA 70. That's the National Electric Code and other standards. Okay. So we don't just modify those. We wouldn't modify those things if we feel like there's a need for having a setting change. We would want to get that reviewed. We want to get that authorized by Marathon personnel. Then also, in addition to that, safe work practices continued. We shall use GFCIs basically for everything that we do. There is an exception in the Marathon standard. That is that if your equipment will not operate off that GFCI, you don't have to use that. Uh, there used to be a time when some of the Doble equipment would trip GFCIs. But I'm not aware of that happening in the near distant past. So we should be utilizing the GFCI protection and have that with us. Okay, labeling. So here's a section that's a little outdated, but I just want you to be aware of it. We talked earlier about all the pieces of electrical equipment shall be labeled. And not only just labeled, but there are some specific parts to this that are pretty good. There says that equipment must be labeled, including, and what they have down here is available incident energy and working distance, minimum arc flash rating of clothing, required level of PPE or highest arc flash PPE category for the equipment. Okay, so they've kind of got some strange wording in here, but basically they're labels. Okay, we have to have the incident energy. So the incident energy is going to be in calories per square centimeter. And to us, the calories per square centimeter, the key is 1.2 calories per square centimeter. Okay. Any equal to 1.2 calories per square centimeter or greater means that you are required to have arc flash protective clothing on. 1.2 calories per square centimeter is the onset of a second degree burn, and we're supposed to be protecting you from that second degree burn. So, incident energy, our big keys 1.2, you got to have clothing on of some kind. Then our next big key is 8 calories. Okay, 8 calories. That used to be the old category 2. That's the clothing that Premier provides for you. Your shirt and pants are category 2. They're guaranteed for at least 8 calories. Okay, so anything above 1.2 up to 8 calories, that's our clothing that we provide for you. Now, you would still have to have your balaclava, safety glasses, hard hat, and face shield on. And understand that that's a little outside what some people try to just tell you. But if you get above 1.2 calories, you're required, if you're working on or near, to have that balaclava, the safety glasses, face shield, and hard hat on, along with your gloves. Then our next best step is if it gets above 8 calories, we're in the suit. We're in the arc flash beehive suit, and that's good up to 40 calories. So our numbers 1.2 calorie, 8 calorie, and 40 calorie. If it gets above 40 calorie, we cannot work there. Okay. So those are the incident energy ratings that we need to look at on the stickers. And then the working distance, okay, that's a little that's a little misleading. The label also has to have arc flash boundary, okay, arc flash boundary. The arc flash boundary should be given in inches. I wish it was in feet sometimes, but it's given in inches. So you're going to have an arc flash boundary. If you cross that arc flash boundary, you don't necessarily have to have an arc flash suit on or arc flash clothing. The key is you cross that boundary and there's somebody working within the limited approach boundary with tools in their hand, or there's a cause to suspect that there is a potential arc flash. Okay. So that's kind of a definition. Then they have the working distance. There are two boundaries there. One is restricted, one is limited. Restricted is the closest that you can get if you're a qualified individual. Okay. Like for a 480 volts, that's going to be 1 foot for a qualified person. Limited approach is the closest you can get if you're unqualified. So again, for instance, 480 volts, that's going to be 3 foot 6 inches. So we're going to be given those boundaries. Then it talks about the minimum arc rating of clothing. That's going to be this incident energy level. They may actually specifically write on their labels what arc flash clothing you've got to have. Required level of PPE or category. This category, they may still use that category, which would be category 1, 2, 3, 4. But the latest edition of NFPA 70E states that if you've got the incident energy on the label, you cannot have the PPE category on it. So I would not expect them to. I mean, Marathon's good about following all the policies, and so they may not just have changed this policy or altered it or revised it to pick up on the latest standard yet. But you should not see the PPE category if you have the incident energy. So also, the electrical distribution panels shall be marked to indicate its function. Okay, so you're going to see the function there. Also, I believe that on their panels, it'll also tell you where it's fed from. So that should be an aid in you determining exactly where you should try to approach and get your electrical working clearance from. So, what's it take to create this electrical safe work condition? So there are certain conditions that have to be met. First of all, the sources identified of the equipment you're working on. So you're working on a specific piece of equipment. Those sources have to be identified on updated drawings and field verifications. So it's unlike most places we work at that you're going to have drawings, and then not only do you have drawings, but you're going to verify the drawings are correct by field verification. Okay. In addition, verify absence of voltage with rated test instrument before and after. So we've talked about that every year in our electrical safety training ourselves, that when you're using a meter to test for voltage, of course, if you're using a meter, you've got your rubber gloves on unless you know it's less than 50 volts, that you're going to test the meter works first, then check for the equipment, and then go back and make sure that the meter still works. For rated test instruments to do the testing, you test each phase to ground, you test each phase to phase, and then you verify that the test equipment functions after the end. So again, test before, phase to phase, phase to ground, and the test equipment, okay? Now, they talk about that, and that's pretty much all they talk about on the electrical safety, but there also needs to understand that we need to have lockout tagout, and there is a mention of it in their policy, but lockout tagout's important, and we can't work on it as if it's de-energized without the personal protective grounding also applied. So we need to understand that as well. Now, Jay, just from your aspect on testing for voltage, I don't believe that we can use electrostatic voltage detections even at high voltage. We actually use voltmeters on that as well. Is that correct?
Yeah, we have to verify. We are allowed to do it ourselves and check, but they want us to verify then.
Okay, yeah. So there is an electrical contact. So they're a little different than any place else that we work with regard to that. So there is an actual verification on a voltage reading. So they've got voltage meters to actually read that, and it's not just a beeper or fuzzer that we deal with. So, okay, so we get away from the electrical portion. We talk a little bit about some other aspects of electrical safety. Battery systems. If you have to work on a battery system at Marathon, uh, part of your job hazard risk assessment procedure has to include not just our electrical hazard, not just our arc flash hazard, but we also have to identify the chemical hazard of working around batteries as well. Uh, I think we typically mention that, but basically, when we do job hazard assessment and job safety analysis, we talk a lot about the electrical safety, which we must, but they want us to also really address the chemical safety and working around those batteries. Then they have a complete section on overhead power lines. So consider overhead power lines energized until proven otherwise. Okay, so that's pretty standard verbiage, but I want us to understand that we should always consider overhead power lines energized unless it's proven dead. And proven dead does not mean that a marathon team member or marathon engineer or anybody from marathon comes up and says, yeah, it's dead. That's not proven dead. Proven dead means verification by electrical test. So they have some other rules. Some of them are a little different than what we're accustomed to, but it says cranes, man lifts, and other mechanical equipment shall not be operated closer than 20 feet without approval of Marathon. Typically, our standard has always been 10 feet, so they're a little more stringent. So basically within 20 feet. So you can't get equipment within 20 feet of overhead power lines. Unqualified persons shall never place yourselves as a person any closer than 10 feet. Uh, Basically for us, I would think that we would want to try to avoid being any closer than 10 feet to an overhead power line ourselves. We're not linemen. Uh, then in addition to that, if we do have mobile equipment or mobile equipment's in the area that Marathon, they're going to determine themselves whether a spotter is required. And if you do have a spotter for the equipment you're doing, you got a scissors lift or a JLG or something like that. If you do have to have a spotter, the only purpose of that spotter, the only job that that spotter can have, uh, is to be doing the spotting, and that's it. So they have also some requirements on temporary power requirements. We don't typically get set up with setting up the temporary power. They do that, but they've got approved cords, they've got approved connectors, they've got approved receptacles. J's on top of that, but you need to be aware of the fact we just can't use what we typically use for cords, connectors, and receptacles. They have to be GFCI protected. Uh, Here's the exception with certain test equipment that will not operate during with GFCI protection. That really doesn't impact us anymore. If you have generator and alternate power, so if you're using temporary power uh, to keep some of their equipment energized. This is different than just to operate our test equipment. But if they're doing alternate feeds, uh, tying systems together. If they set a generator up to operate certain aspects of their business, then there has to be an appropriate form that's filled out, a marathon form that's got to be completed. And then, if we're ever involved in temporary electrical installations, they can be used during construction, but they've got to be completely and entirely removed the minute that construction's done. Energized, safe work practices. Clothing, conductive clothing. So I don't know why we would want to have conductive clothing on, but I guess some people still do. Uh, but conductive apparel are prohibited within a restricted approach boundary. I would say that Premier's policy is a little better than that. You really don't have any you don't have any reason to have conductive apparel of any kind on within the limited approach boundary where an unqualified person can be. So energized conductors and circuit parts shall be put into an electrically safe work condition prior to performing work under the following. Basically, within the limited approach boundary. So before you get any closer than the limited approach boundary, now this is going to be to exposed, energized electrical parts and components. That limited approach boundary, that's where an unqualified person can be. Before you get any closer than that, then you need to be making sure that it's in a safe work condition, okay? We want it shut off, tested dead, locked out, grounded. Or in addition to that, if there's an increased likelihood of injury from an arc flash exposure. So this one's always been crazy to me. It is a statement made in NFPA 70E, but why in the world would I want to work around anything when there's an increased risk of injury or exposure? I got enough problems in my life without taking additional risks, so we don't want to do that. We are told Marathon spend a lot of money on working with racking equipment, those sorts of things. That we want to use remote racking equipment when possible. Now, when we talk about that first line, the conductive apparel, Marathon's pretty good about stressing out exactly what that is. That's keys, chains, rings, wristwatches, any kind of bands, those sorts of things is what they specifically mention with regard to that. Energized work. How about getting an energized work permit? Okay. Well, when would you want to do that? Basically, we would just sit there and say we don't do energized work. If it can be proven that there's a greater hazard or an increased risk by shutting it down and de-energizing it and going through that whole process than there is by going ahead and working on it, then there's a potential to get an energized electrical work permit. That's going to be hard pressed to do. I don't know that I've ever seen that happen because we can shut something down. Infeasible. So an energized electrical work shall be permitted if de-energizing is infeasible due to electrical equipment design or operational limitations. That's a pretty broad statement, and I would certainly hope they wouldn't use that very often. But I guess there could be operational functions where it's just not feasible to shut something down. Now, energized work, less than 50 volts. So less than 50 volts, there are no regulations, so you can work on equipment that operates at less than 50 volts. Okay, that would not require an energized work permit. Now, when we talk about this whole energized work permit, and regardless of what Marathon Petroleum's guidelines are, that even if we go through their permitting process, we would still have to meet PPM's, Premier's energized work permit requirements as well. So if we ever got in a place where that was required, we would go through their whole paperwork process that we'll talk about just a little bit, but then you'd work with Jay and we would have to go through that whole process through our safety group for our own electrical work permit. So when is this energized electrical work permit required? If you're working within the restricted approach boundary or if there's an increased risk of injury. So again, we've got the two boundaries. We've got the limited approach boundary where an unqualified person can get to. We got the restricted approach boundary, which is the limit for a qualified person. If you have a tool in your hand and you get inside that restricted approach boundary, that requires an energized work permit. Now, there are exceptions, and Marathon lays out the exceptions just specifically, just exactly as NFPA 70E does. And we'll go through those things. We can test, we can troubleshoot, and we can do voltage measuring inside that restricted approach boundary, and that does not require an energized work permit. Testing, troubleshooting, voltage measuring. I mean, you've got to, if you're going to troubleshoot a piece of equipment, it's got to be energized. We have to do voltage measuring in order to verify that it's de-energized before we can, apply grounds. So those parts are important. But the second that we get past testing, troubleshooting, and voltage measurement and get a tool out of our hand to actually perform some task inside that boundary, that requires an energized work permit. Now, there are areas where I can do the thermography and visual inspections. I can stand outside the restricted approach boundary and do that thermography and visual inspection. That does not require an energized work permit. So the thing I want you to understand is if you're inside the restricted approach boundary, that's key. Inside that boundary doing work. And they keep adding these things, entering or leaving if the restricted approach boundary is not crossed. You didn't cross the restricted approach boundary, so that doesn't. General housekeeping, if restricted approach boundary is not crossed. I don't understand why we're sweeping the floor, but if you don't cross the restricted approach boundary, it wouldn't require an energized work permit. I would tell you that we want to eliminate these. We don't want people walking in or around the equipment that's not qualified, even inside that limited approach boundary. And we don't want people housekeeping, even inside the limited approach boundary. I mean, put the cover back on before we sweep the floor. Approval. Again, Marathon has their approval process, but again, Premier Power Maintenance, our process would have to be utilized. So, when we talk about actual switching for electrical clearance, Marathon's written out some very specific procedures. They have written electrical switching procedure for all the switching they do. Okay, now we don't do that, and we're not required to do that by NFPA 70E. Our procedure is written down when it's only a complex lockout. But Marathon, even if it's not complex, they do have a written procedure. Those forms have to be reviewed internally. Big key. It's not just an internal review. You are responsible for your electrical work safety, so you have to be doing reviewing also. If they do switching at different times, let's just say that one section of the area we're going to work on that they want to do switching at 8 o'clock in the morning, but they have a little difficulty in getting some other portion down, so that's going to be done at 10 o'clock. They have to be done on different written procedures, okay? So they've taken that step to reduce the possibility of human performance errors. Then there has to be a pre-job meeting immediately prior to the switching. We should want to try to, we should attend that. We should have somebody attending that pre-job meeting, that switching. And then prior to re-energizing, there needs to be test and visual inspections to verify that everything's appropriately reconnected. Employees have to be warned to stay clear and the removal of lockout. And key is grounds and stingers, guys. We've got to make sure that all the grounds and stingers have been removed. Tools and equipment. Safety. Basically for us, if it's over 1.2 calories per square centimeter or 1.2 calories and above, hard hat, face shield, balaclava, eye protection. We also have to have ear protection or hearing protection. So we have to have our ear inserts in. Our hands have to be protected. We have glove protectors for our rubber insulating gloves. Basically, any time that we are 50 volts, equal to 50 volts or greater than 50 volts, we have to have rubber gloves on. That's even for using voltage devices like our Fluke. That's even if you have an insulated screwdriver. The voltage gloves are required with the glove protectors. We have to inspect those before we use them. We need to make sure that the date stamp on those things are less than 6 months. And we make sure that we've got appropriate arc flash protection of our hands. If we are in a situation where we're not using gloves, we're not testing, but we are inside that arc flash boundary, we can't be there barehanded inside that arc flash boundary. Even if you're a spotter, somebody assisting, if somebody's actually working in that area or doing an activity that could create an arc flash, we have to have protection for our hands. We can use the arc flash resistant gloves, but certainly our rubber gloves with our leather outers will suffice for that. Arc flash rated clothing, 1.2 calories per square centimeter above. Their footwear requirements. We have boots that we have to do, and we have to do record keeping documentation that we have been trained and we utilize this equipment, and documentation of the testing of the various pieces of equipment. If we talk about live line tools, hot sticks, prior to every use, visual inspection, annual sticker on it that's been electrically tested. We do that. Uh, Protective ground sets, visual prior to use, and annual testing. We do that on an annual basis. Insulating blankets, I don't know that we use any on site there, but again, prior to use and annually done. So everything's done annually with the exception of your gloves, and they're done every 6 months. Insulated hand tools have to be appropriately rated for the working distance. And even though you may have insulated tools, still requires an energized work permit and the rubber gloves and the leather outers as well. Uh, know the arc flash risk assessment. Know what your boundaries are. That should be mentioned in your job safety analysis. Know what the incident energy analysis is and be able to compare that with your clothing. When we're using test instruments, qualified persons only, they should be designated and utilized. We should know what we're doing. We don't use defective equipment. Everything's properly rated. Marathon has a requirement that all of our meters have to be Cat 3 rating or higher. We've done the meter safety in the last month, but all of Premier's meters should be Cat 4. Again, I mentioned voltage, contact voltage detectors are to be used, not not to be used on low. So you can't use a Wiggy or something so you get lows to check for low voltage. And I don't believe that you can use it for the high voltage either, and Jay's confirmed that. Then the point I mentioned earlier about personal protective grounding, their policy is it shall be factory assembled. So our ground sets would not be acceptable because we build those ourselves. We meet all the ASTM requirements, but it's not factory assembled. Assured equipment grounding program. If we're using extension cords, they have to have been tested in the last 3 months. Understanding our arc flash boundary, these are just definitions. That 1.2 calorie, that's a second degree burn. That is where the arc flash boundary is. Understand that at 480 volts, they don't begin the calculation for 18 inches. So the first 18 inches of your arm is not covered by that calculation. Above 480 volts, they don't begin the calculations to 36 inches. So if you're working on a 5 kV system, your whole body could be inside what that calorie calculation is. Restricted approach, we've mentioned before, qualified person only. Limited approach, unqualified person unless you're supervised by a qualified person. So you could get inside that limited approach boundary if you were supervised by one of our qualified people. Electrical hazard is a dangerous condition that such that contact or equipment failure could result in a shock, arc flash, or an arc blast. So these are definitions that they've developed in their policy. Electrically safe work condition means identified, isolated, checked, de-energized, locked out, and grounded. Okay. Exposed, capable of being inadvertently touched. So anytime you can get closer or could inadvertently touch something, that would be cause for exposure. So we talk a little bit about shock approach boundary. That's again the approach boundary electrical shock. Step potential. We would want to make sure that we are working in an area with a ground grid. That greatly reduces the step potential. If you're working in an area that does not have a ground grid, this is just not likely inside Marathon property because they have enough hazards there that they're going to have a ground grid. But you have to be concerned about the step potential from 1 foot being one place and another foot being another place and a fault occurring. So a couple charts here, and then we'll be done. But nominal voltage level. They came up with the chart, and this is directly out of NFPA 70E, and I only did the qualified person, but limited approach boundary, that's restricted. That's the unqualified person, and restricted approach boundaries for the qualified. So basically, the area you're going to be working most of the time is 150 volts to 750 volts. If it's movable conductor or moving wire, for unqualified person, it'd be 10 feet, typically be 3 foot 6 inches. For you, the qualified person, it would be 1 foot. 751 up to 15 kV, I'll do the qualified only, it says 2 foot 2 inches. Up to 138 kV, which is here, is 3 foot 10 inches. I'm telling you guys, you get above 480 volts, we want to stay 10 feet away. If we have to get closer than 10 feet, we need to huddle up and have another job safety analysis before we get any closer than that. Then they have the chart that talks about requirements for protective clothing. You can still see they're using the outdated chart for category clothing. That's not acceptable anymore to use this chart if you've got the incident energy written on the label, which means that you've actually done an arc flash analysis. So I want us to get away from this chart. Basically, again, if it's greater than or equal to 1.2 calories, but less than 8 calories, less than or equal to 8 calories, your clothing's acceptable. If it's greater than 8 calories, but less than or equal to 40 calories, then we're using the arc suit, the beehive suit. Everything else stays the same with hard hat, safety glasses, hearing protection, leather gloves, leather footwear. We've got our balaclava on, those sorts of things. So that's their chart. Then the only other thing I want to add to this is rubber insulating gloves. It's an area that we fall woefully short on. Basically, guys, if you get the voltmeter, I mean, if I was a safety director and as I was walking around on site, if I saw somebody with a voltmeter in their hand or in their belt or in their bucket or whatever you're carrying your tools around, if you got a voltmeter with you and you don't have your gloves with you, I'd write you up because you cannot use that voltmeter without your rubber gloves on. Unless you knew ahead of time it was 50 volts or less. All right, it is now your turn to ask questions. I am done talking. Any questions out there?
For those without a microphone, you might want to text. You can text Alan real quick. I think he covered pretty much everything we wanted to cover. But that last one that you covered was something that was passed on to me by Dana Watts that they're specifically really watching now. And as my guys know, there's another guy besides Dana that's out there from the corporate that is the Terry Perilou, who is the corporate turnaround guy under Dana for this. He'll be looking, walking around, and coming around. It. He may not be there all the full time, but even the marathon people should be asking these questions. They should know these practices themselves.
So did we cover everything like you thought we wanted to cover there, Jay?
Yes, my main goal with this was to find out. Like I was telling some of my guys this morning, they actually Terry Perilou went and I guess at one site where Shermco was working, and most of their people didn't even have a clue what this is. Like I was telling the guys this morning, we don't expect anybody to know this stuff word by word. All of their practices that they've got written up are pretty intense, pretty thorough. But you need to know what they are, and you need to know where to go look them up. For anybody coming from out of town, if you don't have them on your laptop, we can get those to you so that you'll have them. And if you don't know the answer, say, look, I know where the policy is. I know what the policy is. Let me look it up. And that's what you should be doing if you don't, when you're getting ready to do any of these steps Alan just covered. If you don't remember what he said or what we covered here today, that's why these are for. We'll have some printed copies on the job site along with you should have it on your laptop. Open it up. It takes a second to review and find what you need and make sure we're following their standard. That's what they're paying us for, is to follow this. So yeah, Alan, you did a great job. I think it was very good. It's what we wanted, and I appreciate it.
That's not a problem. And guys, just if you are audited or somebody stops by, it doesn't even have to be Dana's the auditor or anybody else, but we do the electrical safety training, which basically covers most of this to every new team member that comes on board, and we do it every year after that in January. So if you can just remember to say that we do lockout electrical safety NFPA 70E every year, that would help a lot too.
Yep.
Alrighty, guys, I appreciate it. If you have any questions, you let